Hello, guys, and welcome to our class for today. And today we'll be treating an equally important analysis called correlation analysis. Correlation analysis is a very important analysis, and we have actually encountered it somewhere before now. I don't know if you could remember. If you guessed multiple regression. If you guess regression, you're actually correct. Correlation was one of the outputs that regression gave us, but it just gave it as a passing analysis. But in this case, we're going to focus on regression analysis and see how to do it. There's some analysis whereby you don't want to predict the future, you just want to check for relationship between variables, and you just want to do a simple correlation analysis. So let's jump straight into correlation analysis. So what's correlation? Correlation is a statistical tool that helps to measure and analyze the degree of relationship between two or more variables. So what this correlation helps you to just check is the degree of relationship between this variable and this variable. That's all. It just helps you to check what's the relationship between this variable and this variable. It doesn't bother itself with prediction. It doesn't bother itself all those stuff. Just check what's the degree of relationship between this variable and this variable. It describes how one variable behaves if there is some change in the other variable. Now it is called correlation coefficient. It ranges from -1 down to +1. So it is called, the output itself is called correlation coefficient, and it ranges from -1 to +1. I remember I mentioned this as a passing comment during regression analysis. I said that the correlation coefficient, you can never see a correlation coefficient of 2 or 5. It's always from -1 to 1. So if it's 1, that means there's a 100% relationship. If it's 0.9, that means there's a 90% relationship. If it's 0.4, that means there's a 40% relationship. I think this is quite trivial for us to get, and that is it for this slide. So what are the types of correlation we have? Sorry, I'm supposed to have mentioned that we have Pearson correlation. Now, Pearson correlation is one of the types of correlation we have, and this is the formula for it. For those who have statistics background, I know you can remember this formula in class and how you'll be calculating and all that. Don't worry, we're going to show you how to use software to do all that. So one of the analysis is Pearson correlation, and this is the formula for it. So I'm not going to bore you up with it. It's just good to know it. If you want to be using this, all the best for you. Then we also have Spearman rank correlation. Now Spearman rank correlation. This is the formula for Spearman rank correlation. This for ranks, and this is number of data pairs. Now, the other one is used for continuous variable. When we start SPSS, I'm going to explain what I mean by continuous variable, and this one is used for ordinal variable. Those are, have you seen all those kind of analysis where they talk about how much, let's say, how much do you like pizza? You're not here very well, not very well, and don't averagely, and all those kind of things. Now, in those kind of cases, this is the kind of correlation you are going to be using, because this one does not deal with numbers. But in the former, that is the Pearson, is when you have the number. Maybe you want to check how the height of individual affects their income. Just imagine a funny analysis like that. So income and height are both numbers, so you use that one. But if you are using rank, then you definitely use this one. You know this kind of analysis. Don't worry, we're going to do that in our practical class when we start SPSS. Then what's the difference between Pearson and Spearman? Okay, that's what I just mentioned. This one works with continuous data, while this other one works with ranked data. The symbol for this one is R, and the symbol for this one is rho. They call this rho. Hello guys, and welcome to the practical section of our correlation class. In this section, we are going to be looking at a data set. This data set, there's a score of students in mathematics, score of students in English, and score of students in physics. Now we want to find out if there's a relationship between how students perform in math and how they perform in physics. If there's a relationship between the score of students in English and the score of students in physics. Let's just check whether there's a relationship. Naturally, or ideally, we will believe that people who are good in maths should also be good in physics. Is that ideology true? So we can also check it using our correlation analysis. Now, the first, I'm going to be showing us three methods. The fourth one, I'm going to be showing only those who are those who do my assignments and do my work very well. Those who do all my work and assignments, I'm going to show you the fourth method, using one of the add-ins I'm yet to introduce. But for that's going to be one of my special gifts for my extra students, serious students. But let's continue. So in the first method is going to be our formula method, more functions, statistical. Remember when we were using this, and it's called Corel. This formula is called Corel. So in this formula, I'm going to put look at returns the correlation between two data sets. Array 1 is a cell range of values. The value must be numbers, names, array, or reference that contains number. So let's pick this. So in this, let's say we want to find the correlation of this, and in our array 2, I want to find the correlation of this, and I click OK. So it's telling us that there is a negative correlation between math score and physics score. So let me insert a new sheet row here. Alright, so let's say this is correlation. Okay, from here it's obvious that the relationship between, okay, and this is for math and English. Let me just put it here. M and P. So we see that there's a negative weak correlation. I'm going to send an image to the group. Correlation between 3 to 0 are weak correlation. From 4 to 7 are average correlation, then from 7 higher, 0.7 upward are strong correlation. So let's check the correlation between math and physics. So this is math, and let me put physics here. So here it's going to be equals to Corel, then I'm going to get my math, and then I'm going to get my physics, comma, then my array 2. This time around I'm writing it directly. Remember I told us that if we know the formula, we don't need to spend our time going there and typing it. We can just type the formula directly. And here we have a 0.3% correlation. So it means that there's actually a weak relationship between all of them. Now I just formed this data set. It's not a real life data set. Most of the real life data sets I came across, they were not, should I say, self-explanatory enough. So, but this is basically what it does. Now let's try our second method. Now this method 1. The second method is our data analysis method, data analysis toolpath, which is the first add-in treated here. If I click OK, so input range, Let's say I want to find. Now, the good thing about this method is that you can find for all of them together. So I can find for all of them together, and I can click label in first row, group by columns. Okay. So now these are new sheets, home, format, auto fit column width, and this is what we have. So mass and mass is 1. English and maths is giving us minus 0.29, what we saw there. Physics and maths is giving us 0.29. Physics and English are negatively correlated 0.33. Are you see this is amazing? It shows that there's a relationship between the relationship between physics and English is even higher than that of maths and English. Is that not cool? That is one thing about statistics. We don't draw into conclusion. We always want to test to see. Even if you tell a statistician that okay, um, those in SS3 will pass an exam far better than those in JS3. They want to see results. We trust numbers more than opinion. All right. Now, the third method is using our second adding, Control M, correlation, okay, and then our input range now. So our input range, let's say we want to do for math, and then let's do for now. Let me quickly mention this. I hope we know that all this while we have been using Pearson correlation because this is a continuous data set. So we are doing Pearson correlation, test type Pearson correlation, column headed. Yes, that's it. And we are not using Spearman. Remember, Spearman is for ordinal data. Pearson is for continuous or scale data. So I'm going to click OK, and it has given us our Pearson correlation. It still gave us these two, but these two are just you just added it there as an extra, but we are not supposed to use Pearson in this kind of case. Now the next thing is, remember I told us that we can test if our correlation is significant or not. Now in this case, look at where we check whether it's significant or not. Obviously it is not significant because it is way bigger than 0.05. See our p-value here is way bigger than 0.05. Let me draw it so that we can see it better. This one in the middle is way bigger than 0.05. So this correlation is not significant. So there is no significant relationship between the test of students in maths. Which two did we even do, self? I think it was maths and physics. So that's just it. Now the fourth method rather, it's a very interesting method. In this method, this particular adding is the most powerful adding I have seen in Excel. It is called XL Stats. You can browse about it. This adding comes like a full tab on its own. The same way we have all these tabs here, that one comes as a full tab on its own, and it's actually a paid software. Okay, and if you want to get it, there are two ways to get it. The first way is to do all my assignment as at when due, or the second method of getting it is you pay and I'll definitely send it to you. So that is just it about the fourth method. So the last method is going to be among the free gifts I'm going to give those who are very serious with my class. So I'm going to be waiting to hear from us, and then I'm going to drop an assignment on correlation on the group chat. So I want us to attempt it and send the feedback as soon as possible. So that is all for correlation, and I guess I'm not forgetting anything. Also, This t value has its own formula. Remember when we're doing that, we only did just for calculating this person. There's a formula for this t value, and then, but I don't want to bore you with all that. You can always check it up online. But the basic thing is, this is what we are interested in, whether it is significant or not. So thank you and see you in our next class. Bye for now.